Now she's like, Anthony, we're just straightening her. I'm like, I don't know how much is it.
All right, page 2. How many selections of 3 CDs can be chosen from 15 CDs? So again, you really need to think about, does order matter or does order not matter? Does it matter what order I choose the 3 CDs in?
No.
No, because no matter what, if I get to choose 3 CDs, I'm going to end up with 3. It doesn't matter which one I choose first, second, and third. Okay? So therefore, I can't do my 3 lines on this. This is a combination problem. When order doesn't matter, it's a combination. So that means my problem is 15C3. And that is how I'm going to find this answer. So what's going to end up being on the top? 15. On the bottom will be 12. Good. And 3. So I write this one out. And so I have 15 times 14 times 13 times 12 ... over. And I'm going to have my 12 ... And then also 3 times 2 times 1. Okay? So then we go through to cancel these out, and my 12s and the ... cancel. Well, 1 doesn't matter. And then I'm going to go 2 goes into 14. 7 times. 3 goes into 15.
5 times.
5 times. So I have 5 times 7 times 13. And my answer is
455.
455 is correct. Thank you. Okay. Questions there? Okay, number 9. A group has, this is where you have to pay attention. Okay, there are 8 men and 4 women. Notice how I'm circling 1 and underlining 1 because you're going to pair them up. How many ways can a committee of 3 men and 2 women be formed? Whenever you see committee, it doesn't matter which order you're selected for a committee. If you're chosen for it, you're on it. It doesn't matter if you're the last person chosen or the first person chosen. Okay? So remember that committees are always combinations. If you have men and women, you're going to have to do 2 different combinations. A combination for your men and a combination for your women. So how am I going to write my combination for my men? Good. 8C3. That's why I circled these, so I know, okay, men and men. My big number in front, my smaller number in the back. Times, when you get the answer, you're going to multiply them together. And for my women, it's going to be 4C2.
So what order do you know to put like C and all
So you always do your bigger number first, smaller number last.
Okay.
Okay? So when we go through this, you ready, gentlemen? Focus. On top is always your bigger number, so I have 8 on the top, and then on the bottom I'm going to have what? 5 and 3. I get the 5 because 8 minus 3 is 5, and then I always have the smaller number on the bottom. So when I work this one out, I'm going to have 8 times 7 times 6 times 5 ... over 5 ... for this 5, and then I also have a 3 times 2 times 1 for the 3. Am I going too fast?
No.
Okay. The 5s and the ... cancel out. So these are gone. 1 doesn't matter. 3 times 2 is 6. So all I have left is 8 times 7, which is 56. So my 8C3 is 56. Times it by, and now I need to find out what 4C2 is. So on the 4C2, what's going on the top? 4. And on the bottom? 2, and then another 2. Since these numbers are small, I'm just going to write it all out. So 4 factorial is 4 times 3 times 2 times 1 over 2 factorial is 2 times 1, and the other 2 factorial is 2 times 1. Okay, my 2's and my 1's cancel. This 1 doesn't matter. 2 goes into 4 2 times, so I have left a 2 and a 3, which makes 6. So now I have 56 times 6, and when we multiply that together, we get 336 is correct. Okay. Questions on number 9? Okay, number 10. How many different 5-symbol arrangements can be made? Well, first of all, do you think order matters in a symbol arrangement?
Yes.
Yes. Okay, codes, symbols, all those things, order matters, okay? So it's a 5-symbol arrangement. So I'm going to write out 1, 2, 3, 4, 5 blanks. Okay? If the first 2, so these first 2 right here, must be from the letters A, B, C, and D. Okay, so how many choices are there?
4.
4. And the last 3 must be from the digits 3, 4, 5, 6, 7, and it says no repeats. Well, how many numbers were there?
There are 5.
5. Okay, so these first 2, it says no repeats. I had a choice of how many letters? 4. So my first blank is 4, and my second blank is 3. Then we move on to the digits. My first one is going to be 5. There's 5. 1, 2, 3, 4, 5. Then my next one will be 4, and then 3.
Wait, why did you start with 4 in the first one?
It said the first 2, if you notice here, it says the first 2 must be from these letters. A, B, C, and D.
Oh.
So I had a choice of 4 and then 3, because those 2 are coming from those letters, and no repeats. And then the last 3 are from those digits, and there's a total of 5. We multiply all that together, and we get 720 is correct. Okay, are we good with number 10? Okay, 11. A jar contains 3 blue, 5 red, 4 yellow marbles, and 2 green marbles. If a single marble is picked at random from a jar, find the probability, which means it will be a fraction, that a blue or yellow marble is picked. What does or tell us? We're going to add. Or means add. Okay, so what is my total of all the marbles? 14 is correct. Okay, so from there it says the probability that it's a blue. How many blue are there? 3 out of 14. Now, did it say that, okay, we're picking a blue or a yellow, so we're adding, and how many yellows are there? 4 out of 14. Now, whenever you're adding, you need to make sure to subtract out if anything overlaps. Can blue and yellow overlap? No. So we just add those together and we get 7 over 14, which reduces to, it's too bad some of you are not paying attention right now. Okay. Number 12. There are 6 nickels, 8 dimes, and 4 pennies in a purse. How many total coins are there? Good. Suppose that 2 coins are selected without replacing the first one. What is the probability, which means my answer will be a fraction, of selecting a penny and then a nickel? What does and mean? Multiplication. Okay, so of selecting a penny, how many pennies are there? 4 out of 18 times. Now, it said without replacing. So how many coins are in my bag for my second choice? 17, but they want to know a nickel. Well, how many nickels are in there?
6.
There's still 6, okay? Because we didn't take out a nickel, we took out a penny. Can anything cross-cancel and reduce?
Yes. 6 and 18.
Good. 6 divided by 6 is 1, and 6 goes into 18 3 times. Can anything else reduce? Nope. So we multiply tops to tops, bottoms with bottoms, and we get 4 over 51 is our answer. Okay? Questions on 12? Yes. Yes. Too bad we're not paying attention. Okay, number 12. 13. Okay, 13. A card is to be selected from a deck of 52 cards. What is the probability that it is a club or a face card? Which means I'm going to add, and we also know our answer is going to be a fraction. So, the probability that it is a club. How many clubs are there? 13 out of 52. Plus, how many face cards are there? 12 out of 52. If you have a hard time with cards, remember I'll leave the cards on the board, okay, how they're all written out. And then how many face cards do any overlap with the clubs? 3 of them, right? So we have to subtract 3 out of 52. So 13 plus 12 is 25, minus 3 is 22 over 52. And you can reduce by 11, no, you can reduce by 2, which gives you 11 over 26. And that is your answer. Okay, questions on 13. Okay, 14. A bag contains 9 blue marbles and 5 red marbles. So what is my total? Okay, total equals 14. Okay, 3 are selected at random without replacement, what is the probability that all 3 are red? Remember, you're looking for or. If you don't see or, then it's an and, okay? So they're choosing 3, okay? So, and they're not replacing them. So how many reds are there? 5 out of 14. And we're not replacing them. So how many do I have now? 4 out of 13, and then 3 out of 12. Very good. Can anything reduce? Okay. 3 divided by 3 is 1. 3 goes into 12 4 times. Can anything else reduce? We can even just do 4 and 4. Is that okay with you guys? So 4 divided by 4 is 1, and this one 4 divided by 4 is 1. And 5 will not reduce with anything else. So on the top I have 5 times 1 times 1, which is 5. In the denominator, 14 times 13 times 1 is
Big number.
182. So 5 over 182 is my answer. Any questions on this page?